Well, it's been a busy week, but this is one of the last cuts, and then I'll be done with this entire assembly. Well, that was suboptimal. On the plus side, at least the camera was rolling for that one. My suffering is your content. Hello, Internet. My name is Quinn, and this is Blondihacks. If you're following this series, you know I've been working on the water management system. However, I have to put that on hold because the boiler needs to go on before we can finish all of the plumbing. And the boiler can't go on until we've finished a few more systems in between the frame rails. So to that end, today I'm going to switch gears and start on the lubrication system for this locomotive, starting with the tank for the oil pump. So let's go. Down here on the rear driver, you may recall there's a second eccentric over here, and this drives the oil pump, or in steam lingo, the mechanical lubricator. It sits right in here, driven by another connecting rod, and there's an oil tank that's going to sit in there. There's a window in the frame so we can see the sight glass on that tank, kind of neat. And the outlet of the pump on that tank feeds oil forward to the steam manifold and injects it into the steam going into the cylinders. And that last little point is important. When we're talking about mechanical lubrication on a steam locomotive, we're mainly talking about the cylinders. Just like with internal combustion, the pistons inside the cylinders have to be lubricated. Now, lubricating a steam cylinder is quite a challenging thing because steam is an incredibly powerful cleaner. We make steam cleaners for a reason. Any normal oil that you try to inject in there is just going to get scoured off of all of the surfaces, and it isn't going to last more than one stroke. So, very smart people in the Victorian period figured this out, however, and there's something called steam cylinder oil, which is a compounded oil. Now, compounding means it's got special additives that prevent the steam from being able to scrape it off of the surfaces. The traditional additive for compounding an oil is beef tallow, and in fact, the modern steam cylinder oils still use this beef tallow in many cases. Sometimes the old ways are still the best ways. With an older and or simpler locomotive like I'm building, we're only talking about steam cylinder lubrication. The lubrication of the chassis and the running gear, all those other moving parts, is all done by hand with a guy in striped overalls and an oil can. However, later and more sophisticated locomotives did use mechanical lubrication for the chassis as well. For example, here on CPR 2816, this is an H1B Hudson class. You can see the mechanical lubricator here. That arm is driven off of the valve gear, and you can see all those little copper tubes running out of it that go off to all the different moving parts of the locomotive. Almost the entire running gear and chassis of this locomotive is automatically lubricated. Very cool. Now, steam engine locomotive lubrication systems are total loss oiling systems. That's different than, for example, in your car, which is a fully self-contained lubrication system that's pressurized. In a pressurized oil system, you regulate lubrication with oil pressure. In a total loss system, you regulate it with oil volume. So that ratcheting arm is calibrated to deliver a specific volume of oil on each stroke or each cycle of the engine. And that is the same system that we are building, but we are going to start with the oil tank that houses everything. As is typical on these drawings, these are imperially dimensioned parts made with metric materials. Luckily, in this case, I was able to source the metric brass plate, and that's going to make this assembly quite a bit quicker. I won't have to create any custom stock, as I've often had to do on this project. So I rough cut and shaped all of the plates that are going to form the sides and the bottom of the oil tank. Alone or in pairs, the shaper makes a clickety sound. Most of these parts have one or more unfinished edges because the final outside shape of the box is going to be filed down after everything is silver soldered together to make sure that we end up with a nice square box, regardless of the vagaries of silver soldering. I will, however, need a more effective way to hold them together during that process. If you've been watching this series, you already know the answer. It's lots and lots of tiny, tiny fixturing screws. 32 holes, in fact. 16 threaded and 16 clearance for number 0 screws. These are incredibly tiny, but they are small enough to fit on the edges of these little brass plates, and they are a very, very effective form of fixturing for silver soldering. So this took a little time, but Some end stops and other techniques sped it up a fair bit. I've learned the hard way on this project that it is never worthwhile to try and take a shortcut on the fixturing of silver soldering assemblies. You always want to take the time and do the screws, and even though it takes time, it's always worth it because it guarantees good results. And the bottom plate has a whole bunch of holes in it, of course, because it has to screw into all of the side plates. And that gets stuck on there like so. Before I go any further, I'm going to want to do the sight glass opening on the front of the oil tank. And this is going to take some thinking. Looking at the drawings, Kozo actually specifies a piece of actual glass for this window. And as you can see in this drawing, he's specified a very specific dimension for that glass that has to be pretty much right on because it's rabbited into the front brass plate, which isn't very thick. So there's not a lot of wiggle room there. And believe me, I tried to source a piece of glass that thin, and I could not find anything. I don't know where Kozo found that piece of glass, but I'm not able to find anything like that. So I thought, well, maybe I can use acrylic instead. I wasn't able to find acrylic in that dimension either, but I did find this piece that was pretty close. It's 9/1000ths thicker, so I think I can make this work. But before I even try it, I need to know, can I cut and machine this stuff, and is it compatible with steam oil? I mean, it probably is. They ship this stuff in plastic bottles, but not all plastics are the same, of course, when it comes to petrochemical compatibility. So I threw a couple of pieces of it in some steam oil overnight and checked to see if there was any ill effects, any clouding or any degradation, anything like that. And the answer is no, there was not. So fully compatible, that's great news. The next question then, as I said, is can I cut and machine this stuff? So I made a couple of more test pieces for that. Acrylic loves to do two things, chip and melt. So keeping that in mind, using a very fine-toothed blade on my bandsaw and running it on the slowest setting worked extremely well for cutting it. For machining it, I did some research, and the consensus seems to be you want a very high rake and very sharp tool with a low flute count, which translates to aluminum cutters. So this is an Alumapower 3-flute aluminum cutting end mill, and the other advice is to run it very slowly and take either light cuts or what they call peel milling is preferred, which is to say side milling with a high depth of cut and a very small step over. In my case, all I really need to do is clean up the edges, and that went actually extremely well. So that was good advice. Now, the other thing I wanted to try was seeing if I could machine a rabbet in this material, because if I can thin out the edges of it and recess it into that opening in the brass plate, and thus basically make it fit with Kozo's dimensions. And yes, I squeezed it too hard in the vise and bent it, but that's okay. That doesn't affect this test. I just wanted to know if I could machine a shoulder onto it. And indeed I can. That, once again, went really well. The shoulder is curved because I was cutting straight, and then the piece was curved, and then it uncurved, and now I have a dish-shaped shoulder. But that's not the point. The point is I can machine a shoulder on it. However, after doing the math again, I decided it's really not worth that effort. I'm only reducing the wall thickness of the brass plate by about 9/1000ths, and that's not enough to really hurt anything, so I decided to just go ahead and modify the dimensions for the thickness of this acrylic and make it a simple rabbet joint, just like in the drawings. I went ahead and laid out that window on the surface plate just to give me some sanity checks for my dimensions, but the actual cutting I'm going to do to the numbers on the DRO. I gave myself a punch mark to center up this window because I don't have any outside references on this box that are valid presently. The outside dimensions are all still rough, as I mentioned before, but I want to cut this window now before assembling the box, so this seemed to be the easiest thing to do. The center window goes all the way through, and I was able to do this in a single pass. It wasn't too deep. I used an end mill with the same radius as the final opening is supposed to have, so this was a pretty easy cut. These cuts are going to look very, very woolly. Don't be alarmed. That's because it's 210 hard plate brass. It's not a free machining brass like 360, so it cuts just fine, but it leaves these really ugly looking burrs that are easy to clean up with a needle file. The chips are very sticky and they stick to themselves and to the cut and makes a woolly looking mess. Next, I cut the rabbet area around the opening, again adjusting that dimension to go a little bit deeper to account for the thickness of my acrylic. That seemed to go just fine. And then while I'm in this setup, I might as well drill the mounting holes on either side because I have valid references and I'm set up for it. And that looks good. Obviously, lots of deburring and cleanup to do from the 210 wooliness, but once again, not difficult to do. So that seemed to come out great. So far, so good. I machined a piece of acrylic to suit the size of the hole, and then the corners need to be rounded to fit the radius left by the end mill, of course. And that I did with some emery on a glass lapping plate. And by lapping plate, I mean old picture frame glass, lest you think I'm fancy. I'm not. That was extremely satisfying, though. I got a really excellent fit on that. That fit is honestly probably oil tight by itself. It's so close, but that is, of course, going to get epoxied or siliconed or something in there. Haven't decided yet on the adhesive. Well, I think I've done all that I can without having the box assembled, so time to do that. All of the plate brass and all 16 of these tiny screws went in the pickling acid to get everything clean, and then I reassembled everything with flux on 2 of the joints and solder on 2 of the joints. I need to be able to do the joints all in a horizontal orientation, so I can't do them all at once. However, I am assembling the whole box at once to make sure all of the screw holes and pieces stay properly aligned during this process. So it's a little bit tedious. I had to do 3 separate setups because I can do 2 of the side joints and then the other 2 side joints and then the 4 bottom joints. And in between each of those setups, I have to take apart what's still take apartable, repickle everything, reassemble it with flux and solder in the new set of joints, and so on. So a little bit tedious, but doing it that way ensured an excellent result. Silver soldering very much rewards patience. It really is worth the time to do all the little fixture screws and to do the pickling and to do the little setups. If you do all of those things, you're basically guaranteed results, and it ends up saving you time in the long run because you don't scrap assemblies constantly by trying to take shortcuts. Ask me how I know. The patience pays off, though, as you can see here. Those are all excellent joints. Honestly, those could not have gone better. Like, I'm 100% confident those are all watertight. I will test them, of course, but it went really well. The next step then is to file the heads off of all those little fixturing screws, and if done carefully, these screws will disappear and you'll never know they were there. This is always a really satisfying process, honestly. A little bit of cleanup, and now I'm going to take it over to the mill and mill off the excess material that is all around the outsides of the box because I need some references for the final couple of operations. So now's the time to make it into a box. Figured I would just take a few quick side milling passes like this. That's going just fine. I was taking really light passes here because I didn't gronk down really hard on the vise because I was worried about crushing this box. It is a hollow box, and after silver soldering, brass is often soft because the silver soldering temperature is quite close to the annealing temperature of brass. Thus, it's pretty common for the assembly to be soft after it comes out from under the torch. The first side went great though, so second side, I got a little impatient, increased my depth of cut a little bit, and, well, you saw the cold open, you know what happened. Yeah. That was heartbreaking. Let's look at this frame by frame so you can see what happened. The end of the end mill grabbed a burr that was sticking out on that back edge and lifted up on it. The vise wasn't tight enough, and once it started climbing up that end mill, the right-hand helix just pulls the part up and lifts it right out of the vise and rips it to the side and drags the side flutes all the way across the front of the part, and you end up with this delightful tiger-striped carnage. Yep. This was a real bad moment, let me tell you, because I had about 6 days of work into the part at this point, and I just literally set it down just like that, shut off the machines, shut off the lights, walked away from the shop, and it was Friday, so I just did other things for the rest of the weekend. At times like this, I find the best thing to do is just walk away. If you try to, in the moment, fix it or come back from it, you're going to be worked up, you're going to be frustrated, you're going to be emotional, you're not making good decisions. It's better to get some space, get some distance, go do something else, get your mind off it. In this case, I actually went and put the winter tires on my truck because it's a chore I had been procrastinating on, and that cleared my head. And Monday I came back into the shop with, honestly, intentions of redoing this whole assembly. I thought, you know what, I'm just going to scrap it, I'm going to redo it, it's going to take another week, but it's the right thing to do. And then I got looking at it, and interestingly, the acrylic still fits. So the window area was not affected at all. Like if there was even the tiniest bit of distortion, that acrylic wouldn't fit anymore because it's such a close fit. So that was kind of encouraging. The other thing I noticed is that the damage is all really cosmetic on the front face of the box. All the back and sides are still fine, and importantly, while there's a couple of nicks here and there, the interior of the box is completely unaffected. So that's definitely still watertight. None of the joints were compromised. And a lot of the damaged areas, like this lower corner over here, is actually mostly going to get machined away when I make the mounting flanges. So I started to think, I wonder if I can save this. I mean, it's only going to take me about a day to try, so what's the difference between losing 6 days or 7 days of work? So I straightened the flanges out, and then I put it in the mill, and I milled the carnage flush with the nominal dimensions of the surfaces where they're supposed to be, and then took another look at the situation. And again, this lower left corner here is all going to get machined away as part of the mounting flange, so there's really not a lot of damage left after all of that. And importantly, all of that damage is going to be sandwiched up against the inside of the frame rail when the tank is mounted in the locomotive. So it'll be literally impossible to ever see any of this damage. So now I got to thinking, well, all right, let's keep going with trying to save this and see what happens. Again, I can still scrap it at any time, and it's only going to take me another day to try and save it, as I said. So I decided to finish the box as I was supposed to do, this time with filing. I'm not gonna try milling it again. I learned that lesson the hard way. And, well, the box came out, frankly, pretty great. I'm really pleased with how that's looking, other than the damage on the front. So let's keep going. If I were keeping this assembly, the next thing to do would be to cut the flanges on the front. So I laid those out around my mounting holes. And, well, now we have a new problem. Those mounting holes are supposed to be centered on those tabs. And I triple-checked the dimensions of the tabs. They are correct, so the mounting holes seem to be in the wrong place. And sure enough, I measured them with the height gauge, and those holes are in the wrong place. I really don't know how that happened. Unfortunately, the fix is, well, the last resort of the amateur scoundrel, and that's to slot the holes. Nothing makes me feel like more of a failure than slotting holes, because it only means you didn't do something right. Before I actually cut the flanges, however, I'm going to do a test fit in the frames just to make sure that my holes are sufficiently slotted. And that looks like that's going to work. That window seems to line up well with the frame, so let's proceed. I adjusted the dimensions of the flanges so that the slots that I cut are centered. If you can't fix the mistake, at least make it look intentional. Once again, not going anywhere near the milling machine, these flanges were done with fret sawing and filing. Incidentally, I did consider milling away the entire bottom corner where the damage was, but there was no way to eliminate all the damage doing that, and it would have been a lot of extra work that I don't think was entirely necessary, because I had another idea for how to fix it cosmetically that we'll get to. The next step, though, was to set it up in the milling machine. There was really no choice. I had to do it this way to mill down the center area to create the little flanges that get the slots cut in them for the lid to slide in. So we need to cut little grooves in each of those uprights now so that the lid will slide in. This is a piece of scrap that's the same thickness as the lid. It's not the actual lid. The lid won't have holes in it, of course. Now there's a couple of ways I could do this. One would be something like this Woodruff key cutter. It's got a flush bottom on it, which is important so that the slot can be cut exactly flush with those front and rear edges. This would work. Unfortunately, this cutter is the wrong thickness. It's about 10 thou too thick. So I could change the dimension of the lid or something like that. This might work. You can't use a slitting saw because a slitting saw arbors are not flush with the bottom of the saw, so the center of the arbor is going to hit the piece. These slots have to be perfectly flush with the front and rear edges, as I said. I had another idea I wanted to try, though. It occurred to me I could probably do this with the shaper. I dug through my high-speed steel bin and I found this old tool bit that some past machinist has ground for something, and it's actually pretty close to the tool I would need to cut these slots. All I really needed to do was square up the end of it so that it'll cut a square slot profile instead of whatever was on that tool before. And that hook shape that it has is just right for getting in to the side of the material with all the right clearances and translating sideways and cutting this slot. I did a test cut on a piece of scrap to see how well this would work. This was a partial success. The dimension came out great, which means my tool grind was good. The lid material fits perfectly in that slot. However, you can see the top of the piece got all mangled up. That's because it's a delicate little shelf of brass that's getting banged into on the idle strokes by the tool as the clapper box does its work. There are some big shapers that have automatic tool lifters for this sort of situation. I think one of Adam Booth's big shapers has this. However, of course, I don't have that. But what I can do is just do one stroke at a time and manually lift the tool on the back strokes. This might seem tedious, and it is a bit, but these are very small, shallow cuts, so I really only have to do about 10 strokes, and I only need 2 of these slots, so this really isn't a very big deal. And that definitely fixed the problem. The end result of that cut was excellent. It's a nice square slot, and the dimension is right on. The lid material fits perfectly in there. So this really seemed like the way to go. I was really pleased with that. And I started setting up the actual part to make these cuts. Of course, I have to get the top of the box perfectly level with the ram so that these slots run perfectly parallel to the top of the box. That took some doing, but I did manage to do this. However, while I was setting this up, something happened. I was touching off the tool to get ready for the cut by hand. I was just moving the ram in and out by hand, and the tool snagged a burr on the back of one of the panels, and the part moved a little bit in the vise. And I was like, oh, here we go again. Sometimes the universe gives you a warning and you gotta listen. It was clear that if I could do that by accident, just by touching off the tool by hand, that's probably going to happen on the real cut too, and that would be much more fatal to this part than the milling machine whoopsie was. If the shaper snags this part and flips it around, it's just going to obliterate it. So yeah. I took that warning shot from the universe and decided to find another way to do this. The fact is, this brass box is kind of difficult to hang on to. It doesn't seem like it should be, but you can't crush down on it too hard, as I said, or you will distort it. And the brass is soft, and soft materials are hard to get a good grip on because they deform under the vice jaws and become loose over time. Now, I could perhaps machine some sort of packer block to fit in the middle that would allow me to compress much harder on the part, but that's going to be a lot of work, and I thought, well, let's try some other methods that would be safer anyway. I kind of had a hunch that maybe the kerf on my hacksaw blade is about 40 thousandths. I don't know why I thought it might be, but I did a test cut on another piece of scrap, and sure enough, that is basically dead nuts. That is a perfect fit on that piece of material. So I don't know why, but this hacksaw blade cuts a perfect 40 thou slot. So I decided to just do this, because this is nice and slow and controlled, and nothing terrible is going to happen. It may not be as pretty a result as the shaper would do, but it'll certainly be functional. It was pretty easy to keep the blade perfectly straight because the vertical edges of the box act as a fence for the blade. So as long as I kept a little bit of light pressure in that direction on the blade, it cut just fine. And I did very careful strokes aligning the blade on each one. And again, it didn't take very many strokes, so this wasn't too tedious. For the second slot, I tried an even lower tech system. I just took the blade out of the saw and flipped it around, turned it into a pole saw, which gives you better control, and this worked even better. Every time I went more primitive with this task, it got better. The next thing would have been sticks and stones, which I guess would have been really perfect, or possibly just screaming and throwing feces at it. Nevertheless, I did end up with 2 functional slots. I made this little test part that'll be the same dimension as the lid, and that slides in and out of there quite nicely. It should slide in, but be snug because you don't want it to vibrate or rattle out, of course. But you should be able to pull it in and out of there by hand. That's a little tight. I'll do some filing on that, but in general, that has worked. Like I said, the result is not as pretty as the shaper would have done, but it's certainly functional. And at this point, functional is my bar. Time for another test fit then. At this point, the bottom edge of that slot should line up perfectly with the top edge of the frame so that the lid can slide in over it, and the window should line up with the, oh no. As you can see, the window in the frame does not line up with the window in the tank. It looked like it did before on the last test fit, but I hadn't cut the slot yet, so I must not have been holding it in quite the right position to verify that with the slotted holes that I cut. And well, yeah. This is not right either. I just cannot win on this thing. I am making every mistake that can be made. I decided to scribe the error for where the bottom edge of that hole is supposed to be and just see how bad it is. And wouldn't you know, the error there on that bottom edge is 40 thousandths. And that is not a random number. That is the thickness of the bottom plate of this tank. So it was only at this moment where I finally understood what had gone wrong that was causing all of these problems for me. I had not accounted for the thickness of the bottom plate of the tank when I was laying out all of these features, either in the DRO or on the surface plate. I was not accounting for that 40 thou thickness. So at this point, I could again scrap the part, but you know what? I am going to sunk cost the fallacy out of this, and I'm going to file down to that scribe line so the bottom edge is where it's supposed to be. Means the rabbet won't be quite even all the way around, but again, none of that's visible on the final part anyway. And now let's drill and ream all of the mounting holes and so on that are needed for the oil pump, the pickup, and the pump body and so on. They all mount to this tank. And there's no rules now. Fork it, here comes the JB weld, or as it's more commonly known, Model Engineer's Bondo. My idea way back when this damage first happened was maybe I can just fill it with some JB weld. Since there's no structural damage to the part, it's only cosmetic. I thought I'll just fill it with JB weld, sand it flat, and then I can either paint or powder coat right over top of this, and maybe you'll never know the damage was even there. This is a type of repair that I have not tried myself before, but it is a pretty common one that model engineers do, so let's give it a whirl. I gave that a full 24 hours to cure, and then in principle I should be able to file, sand, etc. this flat and smooth until it's just filling the negative spaces that were left from the milling cutter damage. Honestly, that went pretty well. This was a fairly straightforward process. I was able to file that square and flush, and I think with some sort of coating on that, that should clean up nicely and hide the damage. Now, when it comes to coating, I was planning to powder coat this, as I do everything on this locomotive, but I needed to know if JB Weld is compatible with the powder coating process. The internet reassured me that it is. The main question is not whether the powder will stick to it. That's a static electrical process, so it'll stick to pretty much anything. The question is whether it can stand the heat of the powder coat curing oven. That oven runs at 205 degrees, and JB Weld's data sheet says it can handle 260 degrees. So it should be okay, and it wasn't. Yeah, I did a little test part, and it failed horribly. The glue was immediately broken as soon as I took it out of the oven. Well, glad I tested it. Instead, I resorted to painting. I have this special Pour 15 all-metal paint that's supposed to stick to all metals without primer. I've tested this paint before, and it's not nearly as durable as powder coat, but it doesn't need to be for this little tank, so it'll be fine. The next thing to do then is to get a nice thin layer of JB Weld around the window frame to seal that in. I tried to put a thin, even layer all the way around, and then I put a bunch of weight on the glass because when there's weight on it, it spreads the glue into a nice thin layer that will hopefully cover the flange. As you'll see in the final result, I should have put more weight on it. Unfortunately, this didn't go quite as well as I had hoped, just like everything else on this thing. Once again, I let that JB Weld cure thoroughly for 24 hours, and I guess I better check if this thing actually holds water. And of course it doesn't. Yeah, it leaks, which is very on brand for this thing. I can see in the window frame where there's a little path for the water to run down out the bottom, so I touched up the inside of that window with a little more JB Weld to fix the leak. That was an easy fix at least. Again, doesn't look pretty, but then I finished up by making the sliding lid for it, and hey, the lid came out nice. The thing to keep in mind throughout this process is that virtually none of this tank is ever going to be visible. It's going to be installed thusly on the locomotive frame. You'll never see it again, so it really doesn't matter what it looks like as long as it functions, and it just really isn't worth the effort, I don't think, to make it again, as ugly as it may be. I know it looks tight in there, but it is possible to get that lid past the valve gear. It's close, but it does go. Well, I wish I could say I'm really proud of this thing, but it is functional and I'm glad it's finished at least and we can move on. I think it's important to have your eyes on the right goal with a big project like this. In this case, my goal isn't to make the best locomotive that I possibly can. My goal is to make my first locomotive, and that means finishing it. My biggest worry with this thing is managing my own motivation. If I get too wrapped up in imperfections in every little corner of it, it's just going to end up being yet another in a very long string of 40% finished locomotives that are filling garages and sheds all over the world. I really want to finish this thing, have that sense of accomplishment, and still have enough motivation to build more locomotives and make the next ones better and bigger. I've done a lot of big projects in my life, and that's the thing that I've learned is that you gotta bite off just enough that you can chew. If you go any higher, you're not gonna finish it, and then you're gonna get discouraged and you're never gonna do any other big projects. So you really gotta set goals that you know you can accomplish, and for me, that means accepting the occasional really crappy oil tank. Sometimes you just gotta roll the hard 6, so say we all. Now, if you'll excuse me, I need to go try and wash the shame off my hands. Out damn spot.